Hello everyone, my name is Shruti Iyer and I'm a graduate student at George Mason University. So today I'll be presenting before you construction of Bayesian networks and I'll be using the software Netica. This presentation is prepared as part of the HAP 823 course on comparative effectiveness taught by Dr. Alemi at the George Mason University. So for the purpose of this presentation, I'll be using the question 1 which has been posted on the text, that is construct a Bayesian probability network model using 5 variables in the model. So here it goes. So the software Netica can be downloaded from anywhere, and what you do is once you enter that, you can enter the limited mode and then click on this icon right here. This will open up a blank screen, and on this you construct your Bayesian network using the tools which are shown here. So this is called the nature node, which is used to depict the variables in the study. This is called the links, with which you create the links between the causal event, between the intermediary variables and the root causes. So you can double click on it and place it here. Sorry. You can always rearrange the positions as per your wish. So what I want to show is, I want to show the root cause event on top with the 4 intermediary variables, and finally the sentinel event, or what we call as the outcome event. Now I draw the links. You can also double click on it. So we want the links from the root causes to the intermediary variables. Alright. Now you would want to enter the variable names. So the first one, as I said, would depict the root cause. So let's say from our STAR-D data that we want to analyze, we want to name the root cause as the family history of depression. So what we do is we click on it. Yep. And here you would name the variable. Since in our data we have it with as a 0 and 1, a boolean type of variable, we would name it as yes or no here in the states. So it's yes, then you press new, then you enter no, and now you do not press new, because if you press new, this Netica will construe it as 3 states for this particular variable, but because we just have 2, we just hit apply, click OK. There you go. You see that the root cause event has been tabulated here. Similarly, you would want your intermediary causes. So we'll take the alcohol abuse as one of the intermediary variables. Hit apply and then click OK. Okay, so now you see that all the intermediary variables are listed in this. So these links which actually show that the intermediary variables are also the direct causes of the sentinel event or the root or the outcome event. I'm sorry. So you want to name the outcome event as CIT success. I'm sorry. Right. Okay. So now you have this Bayesian network. Now what you want to do is you want to import the data. So how you do that is you go to cases, go to learn, click on incorp case file. This would actually import your data. Make sure that you select your data of interest. It's when you select your data of interest, it should be in a case or data file. From my experience, a TXT, converting an Excel or a CSV to a TXT format works the best. And you enter the degree, which is normal is 1. Now what you do is you compile the Bayesian network. Now you compile, there you go. So you see that all the percentage probabilities have already been filled using the data, and you see that family history of depression percentage is 45.1% and no is 54.9%. I would like to show something of your interest. You can click on each of these variables, but I'll be just giving an example here. You hit on this, then you click on table. Now here you see that this table, it shows actually the marginal probability, that is the direct cause which is conditional on the root cause. In our case, we say that out of 100% chances of family history of depression, cases of alcohol abuse diagnosis constitutes 89.578%. Now what you can do is you want to see the impact of CIT success based on these variables. So you can generate scenarios in this case. That's the best part about Netica, that you can create scenarios which predict the percentage change. So right now you see that with 45.1% chance of family history of depression, and given these variables percentage, the percentage chance of CIT success is 60.3%. Also, I would like to show you this, that CIT success is dependent on all the 4 intermediary variables, which are the direct causes of the outcome event. So the Netica actually calculates the probability which is mentioned here based on all the 4 variables. It's dependent on all the 4 variables. Now let's generate a particular scenario and say that the family history of depression, the chances are 100%. Right now the chances are 45.1%, and let's check what if there is 100% chance of family history of depression and its impact accordingly on the CIT success. So you click on yes to make it 100%. You see the subsequent change in the intermediary variables and the change from 60.3% to 60.6% in the CIT success. Now you want to also check for other variables. Let's say there is family history of depression and there is 100% alcohol abuse diagnosis. So you see that right now this percentage change has come down from 60.3% to 60.2%. Similarly, you can check for other variables as well. So let's see what happens if there is no family history of depression. 100% no chance of family history of depression. So now you can see that given that there is no family history of depression, there is 88.9% chances of alcohol abuse diagnosis, 93.8% chance of drug abuse diagnosis, 90% chance of panic diagnosis, 88.8% of obsessive compulsive diagnosis, and which jointly impacts the CIT success up to 60%. So this is how you use the Netica. Thank you very much for watching this video, and feel free to um, provide feedbacks or comments, and I'll be happy to take questions. Thank you very much.